Hello everyone, कैसे हो आप लोग? So today we are going to discuss in the next lecture of the kinematic series the difference between speed and velocity. Speed and velocity. So what is speed? Speed is, let's say, that an object is moving with 10 kmph and no direction is required. No direction, no direction is required. लॉट ऑफ प्लेसेस हमें ऐसे बहुत सारे एग्जांपल्स मिलते हैं जहाँ पे कोई डायरेक्शन रिक्वायर्ड नहीं होती. फॉर एग्जांपल इन रेसेस वी वांट टू फाइंड आउट व्हाट वाज द एवरेज स्पीड ऑफ अ पर्टिकुलर रेसर. एक दौड़ने वाले का, एक गाड़ी चलाने वाले का, एक कार रेसेस और बाइक रेसेस, व्हाट वाज द एवरेज स्पीड ऑफ द रेसर और व्हाट वाज द स्पीड ऑफ दैट रेसर. So how fast did that racer run in that particular race? So in order to specify that, we just need a value. We don't need a direction, because we know that the direction of the racer could be changing or depends upon the track of the race. But direction वहाँ पे important नहीं होती, वहाँ पे important होती है value, and that is what we call as a speed. Now what is velocity in very general terms? An object is moving with 10 kmph northeast. So this entire thing, जैसा कि आप देख सकते हो, it involves two things. First is the value and second is the direction. And since both value and direction are specified, we are going to say that velocity is a physical quantity that involves direction, and it is a vector quantity. Speed, on the other hand, is a scalar quantity. And that is the main difference between the fundamental difference between velocity and speed. But how do we account for those differences in various cases? So let us first look at the case of average speed versus average velocity. Average speed versus average velocity. So let me move this up. Now we are going to look at average speed versus average velocity. Now let's say that a particle moved like this. It started from A, it moved to B, and you have to find out the average speed. ध्यान क्या रखना है, एवरेज स्पीड पे वेक्टर साइन नहीं होता, नो वेक्टर हेड, because it is a scalar quantity. Now what will be the average speed? The average speed will be the length of path AB, as in it starts from A, goes to, let's say, X, then goes to Y, then goes to P, then reaches B. So the length of the path AB, and let me specify this even more further, length of path AB would mean from A to X to Y to P to B to P to B. Okay, so that is the confusion. Alright, so from A to X to Y to P to B. Length of the path divided by time taken to cover the path. Time taken to cover the path. उस पाथ को कवर करने में कितना वक्त, कितना समय लगेगा, and that would be what we call as the average speed. Now what would be average velocity? Average velocity is going to be the displacement from A to B this blue line, as you can see, it is a straight line from A to B. This would even be a vector quantity. The displacement from A to B displacement from A to B divided by time taken to cover from A to B. Move from A to B. And this is the basic or the main difference between average speed and average velocity. And we can actually exemplify this with a few more use cases, questions. So let's see how that works out. A particle moving with a uniform speed in a circle of radius 2 meters covers the entire circle in 2 seconds. Find the average speed and average velocity, or we can just say the magnitude of average velocity in covering or transversing a quarter circle. Quarter circle means 1/4 of a circle. So we have a particle so this could be an x-axis, this could be a y-axis. Let me draw the y-axis. It's slightly okay. I think I've got it now. So this could be a y-axis, and let me name them x and y. And a particle, let's say, starts from A and covers the entire circle in 2 seconds with a uniform speed. So if it covers the entire circle in 2 seconds with a uniform speed, it should cover 1/4 of a circle TQ. Q represents the quarter part of a circle. TQ is equals to the entire time divided by 4, and that would be equals to 2 by 4, and that will be 0.5 seconds. So the time taken to move from A to B would be 0.5 seconds. Now we want to find out the speed. Notice again कि हम यहाँ पे कोई vector sign नहीं लगा रहे. We just want to find out the speed. We are not applying any vector sign. And in order to find out the speed, all we have to do is look for the length of the path that was covered in that particular interval of time, that was 0.5 seconds. So the length of the path is, of course, 1/4 of the perimeter, that is 2 pi r, divided by 0.5. So we can have it as pi r, simply pi r, and since the value of r is 2 meters, so we can very easily say that it is equals to 2 pi meter per second. 2 pi meter per second is your average speed. This is your average speed. Now we intend to find the average velocity, and in order to do that, all we have to do is find out the displacement. So this is going to be your displacement. And how do we find out your displacement? So the displacement is 2 meters, this is 2 meters, this is 2 meters, this is 90 degrees. So obviously by Pythagoras theorem this becomes 2 root 2 meters. So if we want to find out the average velocity or the magnitude of average velocity, we will have to find out the magnitude of displacement by time. And the magnitude of displacement, as you can see, is 2 root 2 and time is 0.5. So this is going to be equals to 4 root 2 meter per second. And I think you would be interested to see down here that these two are very different physical quantities. The average speed is totally different, the average velocity is totally different. And this is the understanding that average speed and average velocity are two totally different quantities. Average speed is length of path by time, and length of path by time, as you can see here, this is the length of path by time, and average velocity is the displacement by time. Okay. Now let's come to the last part of this, and we will discuss what is the difference between instantaneous speed and instantaneous velocity. So this is instantaneous speed and this is instantaneous velocity. As you can see, it has got a direction, so it's a velocity. Now, in order to discuss what instantaneous means, we will take up a path that starts from A and goes to B. And on this path, we want to take a point P and a point Q, that the particle covered, and the particle moved from P to Q in a very small interval of time, that was dt. In a very small interval of time, that was dt. Now something interesting happens. If we take, what happens, I'll tell you. If we take a very small part of a curve, it will be approximated to a, or it will be approximately a straight line. Now that is interesting. And the smaller part you take, the better the approximation is going to be. So if you are going to take a very small part, it will approximately be a straight line, almost a straight line. Now in such a kind of a thing, when it is a straight line, we know that when a particle covers, let's say, from point P to point Q, this is not point P, this is point Q. When a particle covers a distance from point P to point Q, we know that the displacement and the length of path, which can also be called as the distance, are actually equal in value. For a straight line, displacement is equals to the length of path. L is the length of the path. So in this case over here, in the case of the curve, let me move this thing up and redraw the curve again. So if we have taken a curve and we are attempting to find out a small displacement or distance for instantaneous velocity, we are looking at a straight line. This yellow thing over here is approximately a straight line. And since it is a straight line, and since it is approximately a straight line, the displacement, the magnitude of displacement or the distance are approximately same. I mean, not approximately, they are more or less same. I mean, the smaller the value, the better the approximation. So ds is actually equals to dl. The magnitude of ds is equals to dl. Now if I divide this by time dt, because the time taken is actually dt, on the left side we are going to get instantaneous velocity, the value of instantaneous velocity. On the right side we are going to get instantaneous speed. So magnitude of instantaneous velocity is equals to instantaneous speed. Because whenever we are taking small quantities, we are considering, straight lines, and in straight lines distance and displacement are equal in magnitude, and hence speed and velocities are also equal in magnitudes. So the magnitude of velocity is equals to magnitude of instantaneous velocity. Magnitude of instantaneous velocity is equals to the instantaneous speed. Now I want you to be very careful here. You can never write this. Instantaneous velocity is equals to instantaneous speed. Many students do that. बहुत सारे बच्चे करते हैं, and this is a big mistake. Don't do this, please. And why not to do this? This is because this is a vector quantity and this is a scalar quantity. So a vector quantity can never be equal to a scalar quantity. The value of a vector quantity can be equal to the value of a scalar quantity that is given in the first statement, but the second statement is, is something that you have to take care of, that you can never equate instantaneous velocity with instantaneous speed, because instantaneous velocity has got direction and instantaneous speed has got no direction. So the magnitude of instantaneous velocity is actually equals to instantaneous speed, and that is the idea here. Now let's have a look at an example that would help us understand in a better way how these things work out. So a particle is moving along x-axis according to the equation x equals to 4t minus t square. We have used a similar equation before, but okay. So a particle is moving along x-axis with the equation, according to the equation x equals to 4t minus t squared. So what you have got to find? You have got to find average speed between 0 to 4 seconds, average velocity between 0 to 4 seconds, instantaneous speed at t equals to 4 seconds. Now this is a very important thing. I have explained this in previous videos, but I want to reiterate it. Whenever someone asks you an average speed or average velocity, they will always give you an interval of time. They will always provide you with an interval of time. And when anyone asks you instantaneous speed, they will always provide you with, with a time instant at a certain perfect moment of time. So let's start with this. So first off, our job is to see how the particle moves. So at t equals to 0, you can actually put t equals to 0 here, and you can find out that the particle is at x equals to 0. Now there are two ways to go from x equals to 0. Either the particle can move right or the particle can move left. So how do we find out in what direction is the particle moving? So in order to find out the direction of the movement of the particle, we will find out the instantaneous velocity. Instantaneous velocity always gives us the direction in the right way. 4 minus 2t. We simply have to differentiate x versus t. So 4 minus 2t. Now at t equals to 0, you can see that the instantaneous velocity is 4 meter per second plus 4 meter per second. So the particle is moving forwards with 4 meter per second. Now let's say at t equals to 1 second, the instantaneous velocity is 2 meter per second, and we will see that the particle is decreasing its speed. T equals to 1 second, the speed is 2 meter per second. The speed is decreasing. And what is the position at t equals to 1 second? What is the position at t equals to 1 second? In order to find the position at t equals to 1 second, we will simply apply the formula 4t minus t square. So t equals to 1 second will give us x equals to 4 minus 1, that is equals to 3 meters. So x equals to 3 meters at t equals to 1 second. Okay, let's move this. I need some space to write here. Now at t equals to 2 seconds, we will see that the velocity becomes equals to 0, as in the particle comes to rest at t equals to 2 seconds. The speed of the particle is 0. What is the position of the particle at 2 seconds? The position of the particle is 4 into 2 minus 2 squared, so that is equals to 4 meters. So the position of the particle at this point here is x equals to 4 meters. Now what happens? Now if we increase the time beyond 2 seconds, let's say we do 3 seconds, we will have velocity equals to 4 minus 6, that is minus 2 meter per second. Now this is interesting. Okay, let me draw a partition over here. This is interesting because now we can see that the particle is returning back. It is coming back. Why back? Because the velocity is negative. At t equals to 4 seconds, you can again see that the velocity is equals to minus 4 meter per second. T equals to 6 seconds, the velocity is minus 8 meter per second. So you will see that the particle is returning back after 2 seconds. So let me draw this diagram so that I can help you understand in a clean and clear format. So let's see. So this is our straight line. At t equals to 0, the particle starts from x equals to 0, moving with 4 meter per second. The speed decreases slowly. At t equals to 1 second, it is actually just 2 meter per second. And at t equals to 2 seconds, the velocity equals to 0. And after this, we will say that the particle returns back. The particle returns back because its velocity is negative all the time. Now the question is that we have to find out average speed between 0 to 4 seconds. So average speed is length of path between 0 to 4 seconds divided by 4 seconds, that is the time. So what is the length of the path? So in order to find the length of the path, I need to know the position of the particle at t equals to 4 seconds. So coming back at the equation, x equals to 4t minus t square, t equals to 4 seconds will tell us that x equals to 0. So the particle has come back to the starting point x equals to 0 at t equals to 4 seconds. Also, what is the position of the particle at t equals to 2 seconds? That is of interest to us. So t equals to 2 seconds, x equals to 4 meters. So this position is x equals to 4 meters. Now I think everything is clear. The particle moves forward till 4 meters, returns back to the starting point at t equals to 4 seconds. मैं फिर से समझा देता हूँ. ये 2 सेकेंड्स तक आगे बढ़ता जाता है 4 मीटर्स पे पहुंचता है जहां इसकी वेलोसिटी 0 हो जाती है, वहां से वापस लौटता है और वापस लौटने पर यहाँ पे इसकी जो पोजीशन है वो फिर से x इक्वल्स टू 0 हो जाती है 4 सेकेंड्स पे. So what is the length of the path? So the length of the path is 4 forwards plus 4 backwards divided by the time, that is equals to 4, and that is equals to 2 meter per second. That is your average speed. Now what is the average velocity? The average velocity is final position minus initial position divided by time. We all know that. and the final position is 0, initial position is 0 and time is 4, so the average velocity is 0 meter per second. Last point, what is the instantaneous speed? So in order to find the instantaneous speed, we will first find the instantaneous velocity. The instantaneous velocity was 4 minus 2t, that came after the differentiation of this x versus t. Let me write this here, dx upon dt equals to 4 minus 2t. So 4 minus 2t came after the differentiation of this. So at t equals to 4 seconds, the velocity is minus 4 meter per second. The velocity is minus 4 meter per second. But we are not looking for velocity, we are actually looking for speed. So if we are looking for speed, the speed will be simply the magnitude of velocity, because in the instantaneous case both things are equal in magnitude. So instantaneous speed will be equals to instantaneous velocity ka magnitude, and that will be equals to 4 meter per second. So I think this example clarifies your doubts regarding instantaneous speed and instantaneous velocity. And if you do have something to ask, please ask me in the comments. I will try to reply them back, and I will also try to create videos if you have certain specific doubts that are worth explaining in a video. So waiting for your comments, and I hope you understand this idea, and we will see motion under gravity in the next part of this lecture series. Thank you very much.